Hey, I'm going to give you guys a warning. Notability, or the recording thing, is giving me a lot of trouble today. I've already tried to do the 2.7 and it came out in 4 different videos. I'm going to try this one more time to make it fewer than 4. But bear with me as we go. So today we're going to be looking at different types of graphs and how they're placed on a coordinate grid. We're going to see some absolute values like we did yesterday, as well as some quadratics, which we haven't seen yet this year, and some straight lines, which we saw earlier in this chapter. So the biggest thing I want you to notice is really the absolute and quadratic functions, but the identity too. Notice how it does go through 0, 0. And the absolute value and the quadratic functions have their vertexes also at 0, 0. We're going to move these around the graph, and you're going to be able to tell where I move them based on the equations. So we're going to have what we call vertex form. And you're going to want to pause so that you can write all this down. The A value, if it's negative, it will flip the graph. Then A, if it is bigger than 1, ignore the negative sign. If it's bigger than 1, the graph will be stretched. If it's less than 1, the graph will be compressed. Then H. Notice, we have a minus sign with the H. That is going to cause the H value to do the opposite of what you think. I'll tell you now, it is going to move the graph left and right, but due to that negative sign, it will be opposite of what you think. So if you see a +2, that's actually going to be to the left 2. All right, and then at the end with that K value, that will move it up and down. So let's cross our fingers and hope it works. All right. So now what we have is some graphs here. And I'm going to start, I think, just with the regular boring graph here. A straight line, goes through 0, 0, very boring. Now what happens when I put a +2 on the end? My plus B, we know that to be the y-intercept. That's going to shift the whole line up 2 spaces. Now if I make it -2, the whole line goes down 2. That's the whole idea that you're going to see here now with these quadratics. So I have a quadratic here. This is the original, very boring, what we call parent function. And I'm going to leave that there for you to be able to see while I move this other one around. So here we have a purple one. Remember, A, if it's negative, is supposed to make it flip upside down. So let's see if it does that. Beautiful. It goes right upside down. Now what happens if I make it bigger than 1? It should stretch it. That's going to make it skinnier than the original. And notice, the bigger the number I make it, the skinnier the graph gets. See that? Okay, so it's almost a straight vertical line, but it does still have some curvature. Now if I make it less than 1, but again, ignoring negative signs, that's where it's compressed. And notice the smaller the decimal, the fatter it gets. See that? So now what happens if that is negative? Notice if it's a negative, it should flip it, and then I'm going to put a 2. Notice that it is skinnier. Let's do a bigger number. Let's do like 12. Okay, if I zoom out, you can see the graph is still skinnier than the original function, so it is still stretched. Even though I can see that it's upside down. And we're like, well, if it's less than 1, it's compressed. No, if it's less than 1, ignoring the negative sign. Okay, so let's check out, if I go ahead and make this like a -0.2, I can see that it is now compressed because it's wider than the original, even though it is also flipped. All right, let's move the graph. Let's say inside the parentheses I put a -2. We know that because of that negative sign, it's going to move it left and right, but opposite of what I think. So if I put a -2, it should move to the right 2. If I put a +2, it should move to the left 2. Now check it out. I'm going to put the +2, -2 on the outside of the parentheses. +2 moves it up. -2 moves it down. And it still has that same shape. Okay? absolute values are going to work the exact same. If it's negative, whoops, here we go. If it's negative, it flips upside down. If it has a number, ignore the negative sign, a number bigger than 1, it's going to get skinnier. If it has a number less than 1, ignoring the negative, it's going to get fatter, like so. If I put an addition subtraction on the inside of the absolute value bars, plus 3, it moved to the left 3. Minus 3 will move to the right 3. Now let's try an up and down, plus 3, and now minus 3. Okay, so on your homework, what you're going to see is some matching. And you're going to be given a graph kind of like this. And let's go ahead and maybe do something else to it. Perfect. I can see, well, actually, let me back up for a second. In an absolute value, if the A value is 1, that means it is not stretched or compressed. It's just regular, normal, boring. So I can see if it's regular, normal, boring, if the slope appears to be up 1 over 1 on each side, or down 1 over 1. So see how, like, I have my point here, and I can't really highlight that in this app, but I have that point. I can see that it goes up 1 over 1. That means the absolute value, stretch compressed A, is 1. Can you see now how it goes up 3 and then to the left or right 1? That means it is stretched. You can kind of, for that first one, tell where it goes. It's going to follow that slope. So in this matching, what I would do is I'd come over here and say, okay, it looks like it goes to the right 4. That means it should say minus 4 inside the absolute value bars. It goes down 3, so outside of the absolute value bars, it should say minus 3. And it looks like it's skinnier than normal. So it should have, looks in this case like a 3. But even if you can just know that it's supposed to be bigger or less than 1, or a negative sign if it's flipped. Okay. The quadratics are a little harder to tell that on. You have to look very specifically, oops, there we go, at the very first one. And I wish I could highlight on this thing. Let's see that I can. I can see for the very first, come on buddy, there we go. Very first, you know, at 1 and negative 1, it does appear to somewhat have that slope of 1. Now watch what happens if I put a 3 there. See how it comes up to the 1, 3 and negative 1, 3. So that's how you can tell from a graph if it's stretched or compressed. Okay, be prepared for a worksheet tomorrow.